How's everyone doing today? It is Thursday, Haslam Friday. Love it. Tiffany's got the first question here on Chapter 6. I am ending a little bit early today. I have a meeting at 12:15 your time. A Chapter 6 problem, a ceramics factory. Let's check out this Chapter 6 problem on ceramic factories right here. Doing some correlation. How is everyone doing today? Mubot, give them some points. Give them some points, Mubot. We got tests for 201 coming up. Ceramic factory questions. Ooh, I'm afraid to look at them. How many people didn't do their homework last night or their quiz? Don't look at it, Brian. I'm not going to look at it. Make sure you're doing your homeworks and your quizzes. They are the best way to practice the material, besides Canvas content. Different coffee. Not as good. Sorry, Coop. I'm drinking all the coffee. I need it. Maybe that's all right, coffee. We're getting the ceramics factory question pulled up here. Let's go check it out. Good to see you, Tiffany. Number 5. I think we can. So we got Sneha's question, Alyssa's, Mohammed, then we'll circle back to Tiffany's questions. We probably have just enough time to do that. Let's go check out this ceramics question correlation, Chapter 6, 201. Let's go check it out. So with this question right here, what kind of graphic do we have? I need your help today. What kind of graphic do I have in the top right corner right here? Hint, QQ, straight enough, no outliers. What kind of graphic do I have there in the top right corner? What kind of graphic is that in the top right corner? Not of this, but this graphic up here is a what graphic? That graphic is a what graphic? You should see it and say, oh, that's two quantitative variables. That is a this. So when you see that graphic, you say that's two quantitative variables. Instantaneously, you should know it says, especially if you're in my upper level classes. You should be like, oh, two quantitative variables. That's a blank. Starts with an S. Quantitative variables. It's a scatter plot. Good guess right there, Tiffany. It's a scatter plot. Dot plots are univariate quantitative. Dot plots are univariate quantitative. So if you see where dot plots are at, they're over there on the histograms. And take a look right here. We have histograms right here, which you could make a histogram into a dot plot if you just put dots on them. Does that make sense? This is called a scatter plot. Good work right there, Sneha, practicing. Good practice. Scatter plot, 2 quantitative variables. Histogram, 1 quantitative variable. Now, this is where this gets confusing. This question seems really difficult because it wants to know what is the histogram of the broken pieces. And if you notice right here, the broken pieces, I want you to count this way. How many batches were there with 0 broken pieces? Be very careful. How many batches were there with 0 broken pieces? This is the number of broken pieces. And let me highlight it so you can see only that. This is the variable we're looking at. We're looking at just one variable. Don't look at the other one down here. Don't look at the batch number. That doesn't matter right now. Rock.
It doesn't matter.
Don't look at that. Let's go over here and look at batches with 0 broken pieces. How many batches had 0 broken pieces? How many batches had 0 broken pieces? Because we're not looking at the X variable, we're just looking at the Y. How many batches had 0 broken pieces? So just look over here, what I've highlighted right here. How many batches have 0 broken pieces? Who knows? So you have to be like, okay, let me trace across on the 0 and find out how many batches had 0 broken pieces. Do you see how many blue dots there are for the 0? Oh, I'm not on live chat. How many batches had 0 broken pieces? How many batches had 0 broken pieces? Now be careful, these numbers don't matter. We're not looking at these numbers down here. We're not looking at those numbers. We're seeing how many batches. Sneha, great job right there. Sneha, another 20 points. You are correct. It's one batch had 0 broken pieces. How many batches had 1 broken piece? Which this is where 1 would be at. How many batches had 1 broken piece? I'll do the next ones after this. How many batches had 1 broken piece? How many batches had 1 broken piece? So you're just tracing across and saying how many of the batches, because we're just looking at the Y variable right here. So these are the values of Y. Like when you look at the value of Y, there are how many batches with 1 broken piece? The 1 broken piece is over here, and there's 2 batches with 1 broken piece. There's 2 batches with 2. There's 3 batches with 3. There's 5 batches here. There's 1, 2, that's 8. That's a lot. And then there's 3 here. Now this pattern of 1, 2, 2, 3, 5, 8, 3 is going to be right here. 1, 2, 2, 3, 5, 8, 3. And these are the number of broken pieces. And you can see here we have the number broken. It's only looking at the number of broken pieces. There was 0 broken pieces 1 time, 1 broken pieces 2 times, 2 broken pieces 2 times, 3 broken pieces 3 times, 4 broken pieces 5 times, 5 broken pieces 8 times, 6 broken pieces 3 times. And that's what you see over here in this graphic. And being able to trace across and making it make sense is key right there. So just you're only looking at the y variable and making it a univariate graphic. So this is a bivariate. As batch number increases, how does that impact broken pieces? And this is only looking at the broken pieces. We're not looking at that batch number anymore. We're just looking at the univariate sense. So describe the distribution as shown in the histogram. Histograms are going to give us shape, center, spread. Now, we were talking about some shape, center, spread in 474 today, talking about some z-scores and stuff. I tell people those concepts, they remain. So if you look at this, how does our monster man look right here? So good 201 review question on histograms. How's our monster man look right here? Here's our monster man. And tell me about this monster man. So here's the 2 key concepts on the monster man you should see. So the answer's there in the background, but don't look at those answers. Uniform means flat. Uniform, one form means flat. Monster man looks like he's got one head right there. Yep, you got it. Left to the low. Left to the low, right to the high, whatever way the tail goes. Right to the high, left to low, whatever way the tail goes. So he's definitely a left skew monster man. His tail goes to the left right there. What feature of the problem is more apparent in the histogram than the scatter plot? So the scatter plot's really not going to show skew. Scatter plots are going to show bivariate relationships. Scatter plots, instead of showing, I can't speak. A histogram shows shape, center, spread. It might be more uniform. Make sure yours is the one that looks like it. This is shape, center, spread right here. Once again, histograms show shape, which we just talked about, center, which would be median because it's skewed, and spread would be IQR. That's what histograms show. A scatter plot shows different things. I will throw 100 points if anyone knows one of the things a scatter plot shows. There's 4 things scatter plots show to us. Can you name one of the 4 things scatter plots will show to us? They don't show us shape, center, spread anymore. So we're looking at a bivariate relationship right here, like how does batch number increasing impact broken pieces? So what is one of the 4 things that a scatter plot will have us examine? I'll write them all down. Just give me one. I like that. Snare, you're right. Heteroscedasticity is one of them. And so it'll be strength, which is actually part of heteroscedasticity. 201, you don't need to know that. That'll be does the plot thicken. Strength. No, but you are correct. That's a change in the strength. Heteroscedastic relationships have a differing strength. Homoscedastic relationships have a same strength throughout. So you are correct. It is strength right there, Tiffany. Another 100 points. I'll give another 100. We got strength, direction, form. Great job, Tiffany. And unusual features. And unusual features are just outliers. These are the 4 things that a scatter plot shows. Strength, direction, form, unusual features. That's the way I like to say it. This is a moderately strong by the tightness of it. Moderately strong, negative. So there we go with the direction. It's somewhat linear, maybe a little bit non-linear. That's the form of it. It doesn't really have any unusual features, outliers. So we have a somewhat strong, strength, moderately linear form. We have a negative, definitely direction, with no unusual feature outliers. So strength, direction, form, unusual features. Make sure you can look at a scatter plot and kind of talk about those 4 key concepts and how they come to play. So what kind of features is more apparent in the histogram? The histogram is going to show us the skew, the shape. Hey, Roger, good to see you here. Histogram is going to show us the shape. What aspect of the company's problem is more apparent in the scatter plot? We're going to see a bivariate relationship. So the negative, somewhat linear, see, there we go, there's the form, negative direction, somewhat linear form, and yeah, just got it. Great question. That's a really good question. That's a very good, what about yours? Just make sure to look at it. See what looks apparent. Is it negative? Is it positive? Make sure to write down what you think about the strength, direction, form, unusual features, and then make sure your histogram looks consistent. It looks like you're on the right track, Tiffany. Just make sure yours are consistent with how your histogram looks, and then make sure yours is consistent with the scatter plot. A lot of questions. Let's hop to the next question. We're going to do this. We're going to get like 4 or 5 questions out of the way. Let's go do this. We might be able to circle back, and we do have office hours later today too, so we might be able to circle back. Snea had the next question right here. Snea, do you want 2C or 5? But my for loops aren't working. 2C or 5? 2C or 5? Your call, Snea. 2C or 5? I'm gonna load up the assignment right here. We'll try to circle back and do another version of that. 2C or 5? And keep asking those questions. Keep interacting. Great job, everybody. I'm on my second cup of coffee. 2C. Let's do 2C. Here we go. And then I think we're going to do Alyssa's question next, and then back to Tiffany's, and then we'll keep going. We'll keep knocking out as many questions as we can. Question 2C. Let's take a look. I'll just try. Yeah, no worries, no worries. Great job. There's a lot of stuff. Here we go. Let's look at this for loop right here. I'm going to do a similar version of it and show how to do a for loop, nested for loop. Let's check it out. Wrong button. Using a for loop and either sequential or nested ifs create a categorical variable for exclaim. Okay. I want to look how tall people are. This is a similar... Oh, we got yours, Mohammed. Don't worry, we got yours, Mohammed. We'll definitely... I think we got enough time to do that. We got 32 more minutes. So, when you write nested for loops, you don't write the whole thing at once. I'm going to hit my microphone. When you write a nested for loop, you don't write the whole thing at once. I'm going to pull up some data right here because I'm doing similar work. I like to do similar, not always your same work. And I want to figure out if somebody texts a lot, let's say. So with this right here, we're going to go to survey 10. This is a similar question. We're going to go to text per day. This is how much people text. I'm going to describe someone as not a texter is 0. Low texter, less than 50. And high texter, sure, more than 50. Okay. 50 or less. Let's do. Okay. Similar question. Once again, I don't do the exact question all the time. So watch out. Either I do something like it or I do a little bit different. You never know. So read your questions. So here we go. We want to change this variable right here. So the first thing we're going to do is kind of create our first if. We're going to take this variable. And with this first variable right here, we're going to go right here and go if what am I going to do now? I need to know the coding I need to write. Who knows the coding I'm going to write next to this if right here? So I need to know the next thing I'm going to do. So the if takes... Oh, we need to look at the first person because we're doing it within this. Let's look at the first person right here and look at the first person's texting. So let's look at the first person's texting because an if only takes one... Hey, Parker, good to see you here. If an if only takes one logical, and then now we need to do what? I think Snea is getting it right there. We need to put in our coding that we're going to run this if the person's value is true. So what I'm going to do right here is I'm going to put a result. And the result vector is going to have nothing in it, but I'm going to store into result where. Be very careful. Look at my code. I'm going to store not into the full of result, but remember, this is like not a texter. I'm going to store where into result. Take a moment, pause right here. Where am I going to store into result? Where am I going to store into result? Think about this. We're running this code for the first person. We're going to see if the first person texts 0 amount of times. Oh, no, it will be recorded. Try to send me messages on what you want me to do, Snan. I'll try to remember and get it done. I think 5, you said. I'll try to put some help for 5. We don't want a cat yet. That'll put the text in there. That'll put what we want. We can turn it categorical at the end if we want. We could wrap our factor around it and make a factor. So where do we want to overwrite all of result with this? If you overwrite all of result every time you run this, the whole result vector it'll only be one element, and it'll be we don't want to overwrite the whole result element, the whole result object. Where do we want to write into result? Just think we're doing this for the first person. So since we're doing it for the first person, we want to write into result. Yep, Snare, right? Yep, want to write into result position 1. Now, this isn't going to change result position 1 right now. I need to zoom out just a little bit here. It's not going to change result position 1 because this person is not right here a texture, I think. So we still have result as null. What should I add to the end of this now? Maybe, I think maybe it's a bad way to do it the other way. What should I put to the end of this now? What should I append onto this? Because now, if this isn't true, let's run something else. Not like if, but, let's run something else. We could do other ifs. It might work that way. I'm going to do an else, and then I'm going to open it up. I'm going to hit enter right here. Be very careful where you hit your enters. I think I might have messaged someone. Be very careful where you hit your enters because that can cause a problem. You open it up, and then you hit enter. I made so many mistakes on doing this right here. And exactly, we want people who text 50 or less now. So we're going to put another if inside of here now. And you know what we can do? We're going to be reusing this in a moment. So here I'm just going to grab the full if statement, drop it inside of here like this, and do if it's less than or equal to 50, because that one worked right there. And now we go here and we do less than or equal to 50. And now we're going to put low texter. And let's see if we actually have a low texter for this person. Now, if they are a low texter, we'll see result appear with low texter. And it looks like they're not a low texter. Let's take a look and see what they are. This will tell us what they are. They text 100, so they are a high texter. So now we want to go here and go to else. We're doing the same thing we just did. And we're going to grab this right here. And this is where the whole madness ends. Because now we're going to have if they... actually, you know what? We don't even need the if. Why do I not even need the if? I'm removing the if on this because we don't need an if. This is what's going to run if the other conditions are failed. This only runs if the other conditions are failed. So it should run. Let's find out. Hey, it runs. It's the last condition because if the first condition is not met, if the second condition is not met, it has to be the third because we're saying, do they have 0 text? Do they have 50 or less? Well, then if not, they're a high texter because you can't have negative text. You could do 0 or less, but I mean, if you want to be very careful, if someone put negative text, you could do that. I wouldn't do that. I'd say we need to clean our data first. So with this right here, we've got what we need right now. We've got pretty close to something. Let me show you. I might stop here in a moment. What does it look like Brian is building right here? Maybe, let me try this. That does that. This does this. Oh, something's not going on right. Result has high texture in it only. Oh, look at that. That's why you run it. Now look at that. It's doing it. What is Brian building right now? I'll give you a little bit of a hint right here. What do you think Brian's building right there? What do you think we got built right there? Little bit of a hint. Looks like we're building a what right there? Looks like we're building a skeleton right there. How's that looking, Snea? Skelly right there. Yep. How's that looking for going through and building it? Just make sure I want people to always notice how many times I run my code. Notice how many times I'm looking at it. I ran my code 1, 2, 3, 4, 5, 6, 7, 8 times. So I ran my code 8 times in building this. So I built this thing right here 8 times running my code. I swear I ran it more than that. I'm pretty sure I did because this is the full thing. Yeah. Am I losing my mind? Did I not run it more? Yeah, because this is where I'm checking it with the loop. Yeah. Here's my code again right here. Just make sure to run it in those. You know what I'm going to say right here.
Little bits.
Little bits right there. Make sure to run in little bits. From here, we should know what our variable is. Hi. And then we should think about what it goes through, what the elements it goes through. If we built a proper skeleton, it's just going to be as simple as writing our for code, FOR, and then we can take and find our variable and think about the vector it goes through. Because then we have to be like, where do we want it to start? And then what do we want it to stop at? So there should be a code that just gets you 1 through the length of a vector. There should be that. It should be like f length or something like that, like for loop length, like 1 through the length of this should just be f length vector, and then it should just find that. But I mean, it's just 1 through length of vector. Anyways, I'm not trying to give answers. But if you have the skeleton, it's doing it. And then if you need to turn it into a categorical, like for some reason I didn't look, but if this says turn it into a factor, you could just go at the end of it, take your result afterwards. Yeah, take your result afterwards. If a grader takes off for this, they shouldn't. Just do it afterwards. Doesn't matter.
Wow.
Sure. There we go. You do that. Yeah. Wherever it's done, it's done. If you have to turn it into a factor, does it say turn it into a factor? Doesn't hurt to turn it into a factor. So provide a table, good practice, but not required. Order the levels in numeric order instead of alphabetical. So if you want to order the levels in numeric order, we need to go here to levels equals, and then we would go and grab this. I think this will do it. We got to concatenate this vector. I'm going to put it on a new line. If you want to order things, you have to put in a levels vector here. So all I'm doing right now is I'm ordering my vector. I should do it. And let's see. Yep, not a texture, low texture, high texture. It's still not working. I might take a look. I'm doing well today, Parker. Doing well. Trying to get all those Pokemon. See, our friendship level's going up. That's awesome. I'm going to take a look later. I'll probably send you a code. Yep. Send it to me and I'll try to figure out what's going on. Send me an error of the code and your RMD and I'll take a look. We'll figure it out. Got time for at least 2 more. Let's go look. The other question was from Melissa. Can you go over question 1 on activity 3? Yeah, we're going to be doing some of that tonight. Let's hop over to the main screen. We will be doing some activity 3 tonight, but let's go take a look at question 1, activity 3. 320, activity 3. Question 1, activity 3 coming up here, due on Friday. But we are going to be taking a look at it tonight, too. Oh, there were changes made. Save changes. Hopefully that fixed things. Got some friendship data in this. Love it. Question 1, activity 3. Let's take a look. 320. Here we go. Da-da-da-da. We're going to use reg class. Reg class is a package, as in you need to install it first. Make sure you do install.packages reg class if you don't have this installed. What you're basically doing is downloading software to your computer of sorts. Packages are where we get all our neat codes from. Here's reg class. It gives you all these cool things. Whoa.
Wow.
So there's other packages like Gigi Pabar, one of my favorites as of late. Font Awesome. Shout out to Snare right there. Font Awesome. Was working on people's apps yesterday. Shiny widgets. These are all packages right here that just give you stuff. How do you get this stuff? You install it. And after you install it, you need to load it. How do you load a package? You run library. So I've already got it loaded up right here. We're going to go back and look at the global environment. And here we are. After the reg class library has been loaded for regression class, load in the Survey 11 data frame. So this is a survey in reg class. This is not a .csv file or Excel file. This is like a preloaded video game that you get by getting reg class. It's like, congrats for getting reg class. You get some data. And we're all happy. So we're going to load it in. You can tell where any data is located by seeing the name after it. So if you ever type in a data frame and you see like it's in data sets, that means this is part of the data sets package. Like what another one have I been loading in? OS. That's in data sets also. I have to load in other things like watch. Library FPP3. Load that up. That loads up a lot. And now if I go to AUS, we got all these Australian data sets now, like Australian air passengers from FPP3 package. So by loading that library, I got all these cool things. We're not loading those up. We're loading up survey 11. There we go. Okay. This contains information about Stat 1 students, a bunch of variables. Use the associate function, adding the argument. Did I pull up the key? Okay, good. I don't have the key up. Using the associate function. Lost my spot. Use the associate function, adding the argument seed equals 320. I'm going to make this look all pretty right here. I think we got pretty much everything right here. There we go. So that the set default is... Oh, we got to do that. So we got to go here to permutations. 500. This sets how many times we run the randomness right here. Generated for everyone. Does the mosaic plot suggest an association? Oh my gosh, 201 chapter review right here. So we're looking at somebody's gender and their relationship status. Didn't have a comma after that argument. We're looking at someone's gender and their relationship status. Gender is the X variable. Relationship status is the Y. The data frame is this. We're running 500 permutations, and this sets the randomness so we get the same randomness. So let's go ahead and take a look at this right here. And what do you notice? And this is pretty crazy. Wow.
Wow.
I noticed something. 201, good review right here. Parker, what do you notice about this relationship right here? What do you notice about this? Parker's 201. I think we got other. If you're 201, 320, this is a review for your test. What do you notice about these relationships right here? This is in 320. So if you take 201, you could look at this and be like, oh, I see something with this mosaic plot up here. And then we've got the permutations down here, which is a little bit more complicated topic for 320. But what do you notice about this immediately with this mosaic plot? Just look here, look here, look here, look here, look here, look here. What do you notice? Take a moment right here and think it over. What do you notice? Do you see anything going on? You're like, I noticed something. Looks to me like a little more what for what, a little less what for what. These are Stat 201 students, and what do you notice? Let's see what people's thoughts are. 50 points on the line right here. What are your thoughts on this? What do you think about this graphic? A little bit, not quite if they're married. Married is actually one of the ones that's very similar. Muhammad right there, 50 points. Married is very similar based on male-female. But when you look right here, single is higher for males. Over half of males are single, but a little less than half of females are single. Dating is a little bit higher, and complicated is a little bit higher for females. We could go look at the marginal, the conditional distributions. Here's the conditional. Given someone is male, the probability they are single is 50%, compared to given someone is female, the probability they are single is 39%. There's skew in the permutations down below here. But when it comes, we'll talk about that in a second. Good answer right there, ditto. This right here shows that females are a little bit more likely to be dating and a little more likely to have complicated. Then how do we see the p-value? That's such a great question. Ooh, this one gets complicated. So the p-value is the probability of our results or results more extreme happening by random chance variation given the null hypothesis is true. The null hypothesis is that there is no association between these two variables. If there was no association, this mosaic plot would look very flat across, like there wouldn't be differences in the conditional distributions. And the discrepancies would be very, very what? So the discrepancies would be very, oh my gosh. The discrepancies would be very what if there was no differences in the mosaic plot. If it looked like this, the discrepancies would be very, very what? The discrepancies, the measure of discrepancy down here on the bottom, the measure of discrepancy, if they were very close together, would be very, very what? The discrepancy would be very, very what? Very small. Don't worry. 50 points right there. Don't worry. It'd be very small. Now, our discrepancy, this is our observed discrepancy, is not very small. We want to look at the probability of our result or results more extreme occurring by random chance. And every single one of these is a random chance permutation. That makes this thing over here, this amount of area right here that I've circled, those permutations, the what? That makes those permutations that are as extreme or more extreme than our result, the what? Those permutations on the screen right there that are as extreme or more extreme than our result are the what? By definition, remember we said those would be the probability of obtaining a result by random chance given there's no association as extreme or more extreme than our observed result. These are the ones that were as extreme or more extreme than our observed result. That would make that amount, however much of that curve that is, the what? Because it's the probability of a result as extreme or more extreme than our observed result. We observe the result on the red line, which is our discrepancy right here. That is the observed result here at 9.1. And this would be the percent of observed, these are the percent of permutations by random chance that are as extreme or more extreme than our observed result. So hence they're the probability of a result as extreme or more extreme than our result occurring by random chance variation given there is no association. That would make those highlighted results the what? Those highlighted results would be the what? The permutation procedure is used to get us a what? It's used to estimate us a what? The permutation procedure is used to estimate our what? The goal of the permutation procedure is used to estimate our what? P-value, great job, Alyssa, right there. Yep, p-value. So this is actually 3.2% of the shaded curve. Now, our result is inconclusive because we have here 0.05 in the interval. But I want you to think about this. Ready? I'm going to run 5 permutations. And I'm only doing 5 randomness right here. How many of these permutations, like count them, how many are as extreme or more extreme than this over here? How many of the 5 permutations on the screen are as extreme or more extreme than this red line right here, Alyssa? How many, and Mohammed, we might have to do your question on the next office hours because I have a meeting today. How many are as extreme or more extreme than this red line right here? How many of these random permutations are as extreme or more extreme than this red line over here? So how many of these are as extreme or more extreme than this red line over here? Well, so look, here's the results right here. How many of them are beyond the red line? How many of these results are beyond this red line? So you see, here's the results by random chance. How many of them are beyond this red line? Do you see any over here? So how many of these random results right here are beyond this red line? This is our observed result. That is the result we got of 9.1. Well, not all of them. None of them. Great answer right there. Don't worry. None of them. And since none of them are beyond the red line, the p-value is estimated to be 0. Let's try changing this up a little bit more. And so here, I'm going to rerun the code again because I want to get one there. Oh, we're setting the seed. So I'm going to get the same result if I do that. There we go. How many of the results are as extreme or more extreme than this red line? So there's 1, 2, 3, 4, 5, 6. That's the next result right there. 7, 8, 9, 10. There's 10 results. How many results are as extreme or more extreme than our result? So how many of the results by random chance are as extreme or more extreme than our result? So here's our results. And how many of the random chance? There's 1. And it's 1 out of how many permutations? So do the mathematics. It's 1 out of how many permutations? It's 1 out of how many permutations? 1 out of how many permutations? Remember, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 out of how many permutations? Because once you know that, you'd say, well, it's 1 out of this many are as extreme or more extreme than our results. If you do that, it should give the estimated too. Should get an estimator right here. Because it's going to estimate it via the permutation procedure, and it's 1 out of 10. It's 1 out of 10. So since it's 1 out of 10, that's what we estimate the p-value to be. But when we do this, we're doing more than 10 permutations. We're doing 500. So what does this mean right here? These are 3.2% of all the results created by random chance. 3.2% of all the results created by random chance are as extreme or more extreme than our result. And take a look right here. We do have an issue, though, because we are uncertain if our result is statistically significant or not. And now, what do we do if our result, if we're not sure if it's statistically significant? We increase, and this is a huge question for the test, we increase the permutations, and we can go right here and increase it to 1,500, and this will create more permutated results. And we'll actually get a tighter interval now. So now when you look at this right here, 3.2% of the results are as extreme or more extreme than this result, and we think the p-value is somewhere between 2.4% and 4.3%. So what is good about this interval? Last question here on this. What is really good about that interval estimating the p-value? With that interval estimating the p-value, what's really good about that interval? What are we like? Yes, we like that interval. What do we like about that interval? What do we want? How do we want our p-value intervals to look? We do not want what? What do we like about that p-value interval? We're like, that is conclusive, and why? It is, and it's conclusive. So the p-value is significant, and the interval is conclusive. Why? This big question right here, big knowledge thing right here. It is conclusive. Why? So read the bottom highlight portion. And is 0.05 in it or not? 0.05 is in this, yes or no? 0.05 is inside that interval, yes or no? Bingo, let's right there, 100 points, yes. We do not want 0.05 in it because that's kind of our like, we don't want that in it because that means we'd be like, we don't know if it's significant or not. We want to know that the interval is conclusive and is either conclusive significant or conclusive not significant, because we're saying we think the p-value is somewhere between 2.4 to 4.3, which means we think it is statistically significant. If 0.05 is in the range, then we're saying, well, the p-value could be anywhere as low as 1.8 to 5.1, so maybe it's not statistically significant, or maybe it is. We don't like that, so we increase the permutations to get a better estimate. It just gives you a better estimate of the p-value. Mohammed, Mohammed had a question. Let me go grab Mohammed's question. We'll talk about it real briefly here. 475, real briefly, before I have a meeting here. Saw a new Borderlands preview, and now it's songs in my head from a group. If you haven't seen that new Borderlands preview, 5 minutes till meeting. And then regression. I think Mohammed said question 5 for BAS 475. Okay. Let's check it out. Here we go. Question 5 for 475. Let's go check it out. Little bits of hints here. Let's go check it out. So we need to know how to install packages. We were just talking about this for 320. So a lot of knowledge from just the practice of doing things. All the classes have converging knowledge. So it really helps just to review. Install and load a package. So if you were just watching the 320 segment, you'll know install.packages. Now, one thing you may not know is you can't knit these. You can't knit these. You don't want this remaining in here when you knit. So you need to remove that out. Don't knit that. I've already loaded up, I believe. I created the assignment. There we go. Once you type 3 letters, you get the autocomplete. You do want to load it. So you now notice it loaded. I'll just, yes, sorry. Thank you so much. Thank you so much, Tiffany. I really appreciate it. Definitely will. And Tiffany, your questions will be first when we start next office hours. Remind me, your questions will be first, and I'll try to get probably 2 done really well. Thank you so much, Tiffany. I greatly appreciate that. Crazy busy day, right? End of the week. Created TISBL for US total with the year as the index and state as key. Oh, look out, some US total right here. Okay. That's too much. Can you glance? That's not good. I don't like the way any of those are. Let's go ahead. There we go. That's better. Oh, we got this. So we got right here, created TISBOL with US total with year as the index, and state as the key. Oh, I don't want to show it too much. Wait, I'm going to go check out the notes. I don't want to totally give this one away hard, but you have to. So what is the most important thing with working with time series data? Creating a time series object. So I'm going to pull up the notes right here. 2 seconds. The notes are what are most important right here. So I don't want to give this one away. I don't want to write the whole thing. But let's go show the notes for this on how to do this. So we got the part 2 right here, time series notes. And let me go find it. Okay. So we are creating our own TISBOL, time series table. And got 2 minutes. Stuff right here. I'm just saying. Oh, wait, look. And then if you look right here, there's the index. And if you look at what's going on right here, we've got the different things. And think about how yours is going to look. It's not going to have all these things, but I see an index. I see a key. So you can see different variables right here being brought in with they're doing a lot of different things right here, summarizing in a lot of ways. But this is going to allow us to graph our data and do all this great stuff. Probably the biggest hint I can give right here is going to be this slide right here is such a huge hint on how to do it. Don't obviously do everything the way this slide does it because your data is organized a little bit differently. You want to look at your data, think how it's organized, and that as TISBOL function. Like if I'm pointing out anything, that's going to kind of be a mega thing right there. But that's got it. Heading off to a meeting. We'll be back here, everybody, next time on Stats 101. I'll see you then. Bye for now.